back in the FCAT days, if you wrote for a third, if you wrote 0.3, that didn't do it. You have to write lots of threes. So we want to know how tall is the flagpole. What are you going to do? Pythagorean theorem, which is? No, it said the guide wire. I don't know. It says a flagpole has a 50-foot guide wire. Okay? So we want to, and look at the question. What is it asking? How tall is the flagpole? So what do? X squared plus 13.3333 squared equals 50 squared. I'm going to let you finish the math. What's next? Pardon? So you're going to take a calculator and you're going to do 13.33333 times 13.33333. How did I get it? Okay. Were you asking how I square it? Okay. Does that answer your question? Next question. 15. All right. On 15, we have this picture. And they told us on 15 that AXD, that's this whole big angle, is 95 minus X. Then they told us AXB is X plus 20. And they told us that BXD is X plus 30. How are you going to find X to start with? X plus 20 plus X plus 30. Okay, what's this called? Angle addition. So X plus X is 2X. 20 plus 30 is 50 equals 95 minus X. Now what do? Subtract 50 and add X to the other side. So you end up with 3X equals 45. Then what? Divide by 3X is 15. Now they didn't ask for X. They asked for the measure of angle BXD, and BXD happens to be this one. So how do you find it? 15 plus 30 is 45. And I'm telling you now, this would be a multiple choice answer. You've got to make sure you answer the question. Next question. That was 15. Next. Brittany? 20. Oh, okay. So this is, I think this is kind of like a, you're supposed to finish it. 14 through 19, 14 through 25. All right. Given line segment RO, the given description below would result in the construction of a rhombus with one of the diagonals being RO. Does anybody know what a rhombus is? What is it? It's a diamond. What's special about a rhombus? All, very good, Becky, sides are equal. It's, I mean, is a square a rhombus? Yes. But the rhombus does not have to have 90-degree angles. So first of all, they say use patty paper, draw segment RO, and construct its perpendicular bisector. So if I were to construct a perpendicular bisector, let's go through that. Do you all remember how to do that? There it is. How do you do a perpendicular bisector? That didn't happen. Don't you make it what? Where do I put my compass point? Yeah, why isn't it not moving? That's why. All right. On an end point, and then how do I open it? Past halfway. So I put my compass point on the end point. I open this past halfway and do what? Make an arc. Then what do? Flip it, put my compass point on the other end point, and do what? Make an arc. And what do we know about this point right here? And the distance, it is from here to here and from here to there. It is equidistant. If this is equidistant as this is equidistant, what do you know about these two pieces? They're congruent. So what did step 2 say? Mark point M on this perpendicular bisector. Okay, so that would be M. Now, then there's a step 3, which we don't know. Now it says connect adjacent endpoints of the line segments to form rhombus. So I marked M. What do you think you have to do now? So this is, now remember its name is RMO. And they said you're drawing RHOM. So what do you think? We got R, we got M, and we got O. What's missing?
The bottom part.
So what should you do?
At the bottom point.
And what is this? H. So you're going to put H on the intersection of those two arcs, and then you're going to draw in the segments, and you have a rhombus. So what was step 3? To mark H and draw, yeah. Because step 4 was connecting the segments. Pardon? That was number 20. What's next? Let's look at 21. What kind of construction did they do on 21? Look at that construction. What did they do? It's a perpendicular bisector. Is that not the same construction I just did here? It says, using arcs of equal radius from both A and B, a student constructed a line M, which is the perpendicular bisector. Another point C is to be placed on the line N, but not on AB. If points A, B, and C were connected to form a triangle, what kind of triangle would that be? In other words, ignoring the rhombus, what kind of triangle is this? Isosceles. Isosceles means, so we haven't had this term yet. We're banking on the fact you did in middle school. Isosceles triangle is a triangle with two equal sides. Because every point on a perpendicular bisector is equidistant from the endpoints. So if you want to draw an isosceles triangle, it does not matter where, oh, let me get my line tool. It does not matter from what point on that bisector, as long as you connect the vertexes on there, you will always have isosceles triangle. What's next? 19? Okay. So 19 said, a sign maker, this was an interesting one. A sign maker must create a billboard out of plywood that reads last chance gas. Okay? Last chance gas. The total height of the sign is 8 feet. All right, where's my rectangle tool? So the total, that's a triangle tool. The total height is 8 feet. So that means that this has to be 8, correct? And each letter is 4 feet wide. So what do we know about, how many letters do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So if each one of these is 4 feet, how many feet is that? 13 letters, 4 feet each. What will that be? 12. Carry your 1. How about 52 feet? That means this has to be at least 52 feet wide. But is there any space for here? Or for, no, wait a minute. In that 52 feet, do I have spaces? No. Do I have any space between my letters? Well, on the 52 feet, as of now. No. Do I have any borders? No. That's all those letters squished together. Now, it says there is a 12-inch space. What is 12 inches? 1 foot. At the beginning of the phrase and at the end of the phrase. So I was at 52 feet. Where am I now? Right. Now we have our margins, you could say. I'm now at 54 feet, but my letters are still squished together with no spaces. It says there's a 2-inch space between the letters. 2, 4, 6. Now this is just between letters. 8, 10, 12, 14, 16, 18, 20 inches. Right? Okay, that's 20 inches. Now it says there is a, how many sheets, okay, now wait a minute, there is a 12-inch space, there's a 2-inch space between the letters in a word, and a 4-foot space between words.
So in between each word.
Wow. This is 4 feet. Okay, before we go with our inches here, how many, counting in those 4 feet, how much is that? 4 feet and 4 feet, where am I now? 62 feet? All right, now we have to add in 20 inches. How many feet is that? 1 foot with how much left over? 8 inches. So then we're going to add 1 foot and 8 inches. So that's going to be 63 feet, 8 inches. That's how wide this board has to be. Okay? Now they're telling us that we're using 4 by 8 foot plywood. Does it make sense, if it's 4 by 8 and this has to be 8 feet tall, that we put the plywood this way? Where this is the 8 foot and that's the 4 foot. Does that make sense? All right. Are you going to be able to buy 63 feet, 8 inches of plywood? No. Are you going to buy 63 feet or 64 feet? You're going to buy 64 feet. So if you buy 64 feet, the question is, how many, because how much is each one of these? 4. So how many groups of 4 are there in 64? 16. So how many sheets of plywood do you need? 16. All right. I read that letter between is 4 inches instead of 4 feet. I got that one wrong. All right. That's huge. I know. Well, maybe there's this big bridge, you know, like at the Howard Franklin or the Gandhi or the Sunshine Skyway. All right, what's next? What did 18 say? Oh, they drew you a picture. All right, try this again. Now, it's interesting how they drew their picture. All right, so here we are. On 18, it says, Keith drove east from Matagorda So this is Matagorda. So he's starting here. He drives east along a straight route of 40 miles, and then he took to Freeport. So what is the distance from Matagorda to Freeport? 40 miles. All right. Then he took St. Louis Pass Bridge east into Galveston, another 30. This is Galveston. What is this distance? All right. Then he made a 90-degree turn and headed north to Houston. This is Houston. Traveling another 45 miles. Based on the map above, if he had taken a diagonal route directly into Houston, this is a key word, from Freeport, that means he would have driven on this line, not from here over. How many miles would he have saved? So this is our distance. What do you think you're going to do? Okay, what did they give you that you absolutely did not need? The 40 miles. So we're going to say 30 squared plus 45 squared is equal to distance squared. So I'm going to let you finish 18. What's next? Pretty. 22. Oh. Now, they gave you so many different dimensions on this. All right, it says Charlie's going to help his father put a new roof on the garage. New roof, okay? The diagram shows a scale drawing of a garage. This is 22. We just did number 18. All right, this is 22. If you're going to do a roof, do you agree this is part of the roof? Yes? And there should be another side to it. Yes? Okay. Now it says 1 inch. 1 inch equals 6 feet. So what we're going to do is we're going to go ahead and convert as we go. They told us this is 4 inches. How many feet is that? 24. That's 24 feet. They told us that this is 9 inches. So how many feet is this? 54 feet. Do I need this at all? Am I going to put shingles here? No. Am I going to put shingles any place else on the house if they gave you dimensions? Roof only. How do you find the area of this part of the roof? You're going to say 54. 54 times 24 equals what? Somebody. I appreciate that. I need to know exactly what big number. Okay, this is 1350 square feet. Now, are you going to do half the roof or the whole roof? So now what do we have to do to 1350?
Good morning, Paul Hubbard. Please excuse this interruption. We are now going to practice our lockdown. So this is the announcement to notify you that we are practicing our lockdown. Please take all appropriate procedures and follow the flow chart that Mr. Lopez sent out an email yesterday. I'll come back over the air when the lockdown is done. Please make sure that you lock all your doors, cover your windows. Thank you.
Okay, so we're in lockdown. Turn out our lights. However, review goes on. Okay? All right, so have we found out how much square feet we have? Yes? We'll just turn the tree. All right. All right. Now listen. It says each square. All right, the roof. Listen. If you buy shingles, they're purchased in a square. That means a bundle. Okay, but the bundle has 100 square feet of material. So the question is, how many groups of 100 are in 2,700? So we need 27 squares. All right, in order to do this, we need 27 squares. I would buy another square for my screw-ups. But anyway, the squares are packaged in bundles of shingles. 3 bundles make up 1 square. Oh. So there's 100 square feet of each square is. The squares are packaged in bundles of shingles. There are 3 bundles in a square. So if I'm buying 27 squares, how many bundles of shingles are in one of these? 1 square equals how many bundles? 3 bundles. So how many bundles of shingles will I have? How did you get that? So you're going to have 81 bundles of shingles. See, they check our doors. Bundles of shingles cannot be split. All right, so that's how many bundles are needed to buy. Is 54 times 24 really 1350? You got 1,296? As I say, I got something different.
I got that second time I did it.
1,296. What's 1,002? It was nice the other way. What's 2 times that? What's 2 times that? 96. What's 2 times that? it 2005-92?
No, right.
What is it? 92? All right. So now how many groups of 100 are in here? How do you figure that out? Okay, it would be 25.92, but you can't buy 0.92 of a square, so you round that up to 26. And then what's 26 times 3? 78. Sorry about that. Next question? Yes. it was 78 bundles. That was the answer. Uh-huh. No, that's tornado. Okay, somebody mysterious is on campus. All right, 24. The center, we have a circle with center 0, 0, and radius 8. How do you write the equation? I'm sorry, diameter 8, yes. 19? That was 22. I actually labeled it this time. The number 22 is on the bottom of the page, but the problem's on the top of the next. Uh-huh. Okay. How did you get 6? Why? If we know this is 4, and we know this is 9, I have the dimensions of my rectangle. But we don't shingle the triangle. I'm assuming that is not a gable. I'm assuming that is not a hip roof. Yes, there's a gable roof and there's a hip roof. A gable roof looks like this, all right? And there's your house, all right? And a hip roof is like this, where there is no gable. There's no vertical here. That looks like the same picture. But this is like back, inside. Yeah. Gable houses, I think, are prettier. Hip roof houses are safer in a hurricane because with this, the roofs are less likely to blow off. So that's why I didn't do that. But you know what? They didn't tell us what kind it was. So that, in my opinion, it's a bad problem. All right? Yeah, see, I don't believe you needed to do that part. And it looks like they are only doing, yeah. Okay, so let's look at number 24. The area formula for a circle is, equation of a circle, x minus h squared. If you're doing a study guide, y minus k squared equals r squared. What's our radius? That's a D.
4.
How did you get 4? Because 2 radii make up a diameter, so you're going to have x minus the x value of your center plus y minus the y value of your center is equal to the radius squared. So you end up with x squared plus y squared is equal to 16. So then if you go into 25, they have a center. This is what's in your circle. This is 0, 0. This is 4, 3. What is this point then?
0, 4, or 0, 3.
Well, wait a minute. We moved 1, 2, 3, 4 units, and we've gone up no units, right? So how long is this? How high is this? Do you agree that this is the radius of the circle? I don't know if you have a picture. This is that's a rectangle. This is our circle. See it? That's the radius of my circle. So how do you find it? 4 squared plus 3 squared equals r squared. 16 plus 9 equals r squared. R squared is 25. What is r? Square root, plus or minus 5. What if I asked you to, oh, that was 0, 0. So you could then go write the equation of the circle if they asked you. What's next? I'm not sure we have much time. Okay, so what I'm going to ask is I'm going to ask for you to turn in this part of the review, and our paper person on Monday will give this back to you so that you will have it to study with. Monday, bring your major geometry term spreadsheet, because that's what we're going to be doing. We're going to be going through and doing lots of the terms. So please print that.